Good evening, everyone. This is June 2016, Unit 2 of IAL Chemistry. In the first question, how many molecular ion peaks are there in a mass spectrum of 1,2-dichloroethane? So, how we can work out how many isotopes are there in 1,2-dichloroethane? So, when we draw the structure of 1,2-dichloroethane, first and second position we have chlorine, and then hydrogen atoms are there, which only contain hydrogen 1, carbon 12, chlorine 35, and 37. So, what are the possibilities for number of isotopes using this in a mass spectrum? Because if all of them, like the hydrogen is 1, carbon is 12, so the total molecular mass depends on the chlorine. Maybe both of the chlorine are 35 and 35. Maybe one is 35, another one is 37, or maybe both of them are 37. So how many combinations are there? Because of difference in the mass of the two chlorine isotope, it may lead to three different peaks. That's why B is the right answer. Because here 1, 2, 3, 4 hydrogens are there. So it will be 4 multiplied by 1 plus carbon is 12. So it will be 12 multiplied by 2. Then the third combination, maybe both of them are chlorine 35. Maybe one of them is 35, another 37, or maybe both of them are 37. So that's why there are three possible combinations. So B will be the right answer. Four compounds that contribute to global warming: carbon dioxide, methane, dichloro-difluoromethane, and sulfur hexafluoride. Which of these molecule is polar? So for a molecule to be polar, it should be asymmetrical bond. So when we check carbon dioxide, it is a linear structure and the symmetrical bond. So overall, it is not a bonds are polar, but overall molecule will be non-polar. Same thing in methane, because symmetrical bonds are there, symmetry in the bond. That's why it leads to non-polar. But when we check dichloro-difluoromethane, so in this case, because the bonds are not symmetrical, that's why there will be a net dipole moment, so it will be a polar molecule. So C is the right answer. For same case for sulfur hexafluoride, which is octahedral, because the bonds are symmetrical, that's why overall molecule will be a non-polar. 2b, which of these compounds is emitted in the largest quantity by anthropogenic activity? So due to human activity, because we are continuously burning fossil fuels, so we are increasing the amount of carbon dioxide. That's why for question 2 part B, A is the right answer. Which of these compounds deplete the ozone? Because chlorine free radical, which produced only from this compound, and that will deplete the ozone. That's why for question 2C, the correct answer is option C. Which of these molecule has octahedral structure? I just drew sulfur hexafluoride, that is octahedral structure. So D is the right answer. Which of the following is a tertiary alcohol? For a tertiary alcohol, the functional group which is attached with the carbon should have 3 alkyl chains. So when we draw 4-methyl, pentane 2-ol. So pent means 5 carbon. Second position we have OH, and fourth position we have methyl. But when we count, because this is 1, 2, 3, and 4, so fourth position we have methyl group. So this carbon is having only 2 alkyl group. That's why it will be a secondary. When we check the second structure, 3-methyl, pentane 2 all. So third position we have methyl group, and second position we have OH group. Again, you can see two carbon chains are there to a carbon which is bonded with a functional group, so it is also a secondary. When we check the third option, which is 2 methyl pentane 3 all. So third position we have OH, and second position we have methyl. Again, this will be a secondary. And the last option which we are left with 3 methyl pentane 3 all. So pent means 5 carbon, we'll draw 5 carbon. OH group is there with the second, the third, and methyl group is also with the third. So you can clearly see the 3 carbon chains are attached to a carbon which is bonded with a functional group. So it will be a tertiary alcohol. This question is about two isomeric alcohol and two isomeric carbonyl compound. Which of the compound would not produce a color change when heated with acidified potassium dichromate? Alcohol, primary and secondary alcohol can be oxidized, tertiary cannot be. This is primary alcohol, so it can be oxidized. Secondary alcohol can also be oxidized. Aldehyde can also be oxidized to carboxylate, but ketone cannot be oxidized, so it will not give any color change. So D is the right answer. For question 4, part B, which pair of a compound would you expect to both have a singly charged peak at mass to charge ratio of 29? So when we check for these compounds, the peak of these compounds, propane 1 all, propane 2 all, propanol, and propanol. So if you want to check the peaks, we can just write the mass for each unit, like carbon is 12, hydrogen is 13. So this part total mass will be 15. This will be 12, so this will be 14. This will be 14 as well, and oxygen 16 plus 1, 17. This part will be 15. This is together. So 12 plus 2, that's 14, and 14 plus 16, that is equals to 30. And this will also be 15. So when we check this one, this is 15. And C double bonded with O, carbon is 12, oxygen is 16, so it will be 28. And this is also 15. So 15 is there, 14. This is 12 plus 16, so 28. And the hydrogen is 1, or it can be 29 as well. So in the question they are asking which one we can get for 29. So combination, as you can see, 15, we may get 15 or we may get 15 plus 14, that is 29. So propane 1 all can give, so it can be propane 1 all. As well as when you check, this is 15 or it will be 45, 15 and 14. So which peak it is giving, 15 plus 14, so that is also giving 29. So propane 1 all and propanol both are giving a peak at 29. Which of the compound would you expect to give a peak at 31? So how we can work out the peak at 31? So when you check CH2 for the next part, so this is when we read, so 17 plus 14, so that is equals to 31. So for part C, A will be the right answer. As they are asking for peak at 31. And the next part, the infrared spectrum of one of these compounds is given below. Use the infrared absorption in wave number to identify the compound. We have alcohol, alkane, aldehyde, and ketone. So the compound with this infrared spectrum, when you check for OH, it's a broad peak from 3750 to 3200. So, but we don't find any, it's a missing. So it cannot be alcohol. OH peak is not there. Alkane 2962 to 2853, and aldehyde is 2900 to 2820. So a sharp range is there, and 2775 to 2700. So 2900, when we try to check this peak 2900, so that is also missing, so it cannot be an aldehyde. So what it could be, because the carbonyl group of ketone and aldehyde, it is 1740 to 1680. So is there any peak when we check 1740? So 1007, this is 1700, and you can clearly find that because 1600 and 1700, and so there is a peak, a sharp peak is there. So it is propanol, so D is the right answer. Maxwell-Boltzmann distribution shows a distribution of molecular energy. So what happened when we decrease the temperature? So if this was the original peak, so when we decrease the temperature, it will shift towards left hand side and the height will increase. So what happened when the temperature of system is decreased, the peaks will get higher and it will be further on the left hand side. So B is the right answer. And as we increase the temperature, the peak will shift towards right hand side and the height of the peak will decrease. For question 6, this question is about equilibrium of a reaction between hydrogen and carbon dioxide. What effect would of the following changes have on the rate of and the yield? Decreasing a temperature will always decrease the rate of the reaction. Increase in temperature increase the rate, and decrease in temperature decreases the rate. So the rate, what will happen, it will decrease because of temperature. And what about yield? Because the forward reaction is endothermic, so endothermic reaction, reactant have low energy and the product is having high energy. So when we decrease the temperature, equilibrium shifted towards left hand side, so we'll get more reactant, so yield will also decrease, so B is the right answer. Increase in pressure. So when we increase the pressure, equilibrium shifted towards side where number of moles of gas are less. But as you can see, we have equal number of moles. We have equal number of moles for both reactant and product. So the pressure does not affect the rate. It will affect the rate, but it will not affect the yield as the equilibrium is not shifted. So increase in pressure will increase the rate, but yield will remain unchanged. So B will be the right answer. What is the product when magnesium burns in air? So because they mentioned it burns in air, air contains nitrogen, oxygen, so they may react with magnesium, result in a formation of magnesium oxide and magnesium nitride. What happened to solubility of hydroxide and sulfate as we go down? So solubility of hydroxide increases as we go down the group, and sulfate it decreases. So for question 8, C will be the right answer. So down the group, because this is for down the group in question 8. So down the group, for hydroxide solubility it increases, and for sulfate it decreases. But they're asking ascending from barium to magnesium, so we have barium and magnesium. So opposite will happen. If we go up, solubility of hydroxide will decrease and for sulfates will increase. So B will be the right answer. Because I did not read the full question, that's why. According to the normal rule that down the group it decrease and increase, But because it is opposite they are asking, so the trend will change. Question 9. Which of the following substance does not form when few drops of concentrated sulfuric acid is added to potassium bromide? So when we add sulfuric acid to potassium bromide, first there is a reaction in which it will form potassium hydrogen sulfate plus hydrogen bromide, and this hydrogen bromide reacted with sulfuric acid, which leads to products such as bromine, sulfur dioxide. Sulfur might also form, but it does not form hydrogen sulfide. Why? Because in hydrogen sulfide, oxidation number of sulfur is -2, very low oxidation number. It is only possible when hydrogen iodide is reacting. So we have bromine, we have potassium hydrogen sulfate, we have sulfur dioxide, but we don't have hydrogen sulfide. So question 10. 10 cm cube of 1 mole per dm cube sulfuric acid is fully neutralized with 20 cm cube of 1 mole sodium hydroxide. What is the concentration in mole per dm cube? So first we write the equation. When sodium hydroxide NaOH is reacting with sulfuric acid, which is H2SO4, this will result in a formation of sodium sulfate plus water. So the balance equation 2 is there. Because it's a complete reaction, so both of we can use any of the reagent for identifying the moles. So using the concentration and volume, we can find the moles of sulfuric acid. So moles of sulfuric acid is concentration, which is 1.0 or 1 multiplied by volume, which is 10 divided by 1000. So it will be 0.01. And the ratio between sulfuric acid and sodium sulfate is 1:1. So 0.01 moles of sulfuric acid, same number of moles will be there for sodium sulfate, that is 0.01. So we have the moles, but we need a volume. Now what is the volume of solution? Because we mix 20 cm cube with 10 cm cube, so total volume of the final solution will be 30 cm cube. So we divide by 1000, so it will be 0.03. So the concentration is moles divided by volume. So we have moles, which is 0.01, and divided by volume 0.03. So when we solve this, it will come out as 0.33. The total volumes are measured using a burette, with each burette reading have uncertainty of 0.05. So what is the percentage uncertainty? The percentage uncertainty is the least count divided by value recorded into 100. But because we are using, for reading a volume, we use the burette reading twice, so that's why it will be multiplied by 2. So it will be 2 multiplied by least count, because each reading is having uncertainty of 0.05, so total uncertainty 0.05 times 2 divided by volume recorded, which is 10 multiplied by 100, so it will come out as 1% uncertainty. In question 11, in water, hexane 1-ol is less soluble than ethanol. The best explanation: hexane 1-ol molecule cannot form hydrogen bond with water molecule, but ethanol molecule can. So both cases, because hexane 1-ol and ethanol OH group is there, so both can form hydrogen bond, that's why it cannot be A. Carbon-carbon bond are stronger in hexane 1-ol than ethanol, that's wrong, both have the same strength. London forces between hexane 1-ol molecule are stronger than between ethanol molecule, because due to the carbon chain, as the number of the carbon increase, dipole induced dipole forces or London dispersion forces increases, so that's stronger, that's why it is not able to readily dissolve or mix with water. The permanent dipole forces are stronger, both have the same strength of permanent dipole because both have C and O bonds, which are responsible for permanent dipoles. As group 7 is descending the boiling temperature of hydrogen halide, so what we observe: hydrogen fluoride, then hydrogen iodide, hydrogen chloride, then hydrogen bromide, and then hydrogen iodide. So what is the trend? Hydrogen fluoride, then hydrogen chloride, and then bromide, and so on. So first, because of hydrogen bonding, higher boiling point, then there's a dipole-dipole force, but which is weaker. And then as the number of the electron in the system increases, the London dispersion force increases. That's why the boiling point will increase. So first it will decrease and then it will increase. So option A is the right answer. So this was Unit 2 of IAL Chemistry, June 2016.